Hey everyone, welcome back to the 443 Security Simplified Travel Edition. I'm your host, Mark the Liberty, and joining me today is...
Corey Flim Flam Bing Bang Knockreiner.
What?
We'll find out. Bing Bang. It'll come up later.
There we go. As Corey hinted at, on today's episode, we will be discussing a vulnerability involving Bing, as well as a recent supply chain attack targeting a pretty popular VoIP company. And man, what was the last topic on that one? That's right. A
802.11 Wi-Fi industry protocol issue.
Exactly.
That
Super
might
exciting
allow
stuff.
people to see your traffic and inject.
Scary sounding, but we'll get into it in a bit more in just a second. With that, let's go ahead and
Roll on in.
Wi-Fi our way? No. What would that be?
Sleep on in.
Sleep on in.
It
That
has
sounds
to do
good.
with power saving.
I'm also very tired. That sounds great.
Too. Welcome to the travel edition.
So let's start today with the first news story, which is a bit of an update from something that's been kind of ongoing for about, well, at least a week or so in the news, but
not an update for us, right? This is our first time talking about it.
I guess on the podcast, yeah. If you are a reader of Secplicity, you've already seen one post on this. But last week, the enterprise phone company 3CX confirmed that they had become the latest victim of a software supply chain attack that ultimately resulted in malware being delivered to potentially thousands of customers. But we'll actually get into an update from just today that seems to make it even a little more targeted than it first looked at first thought. So this saga actually began a couple weeks ago when users on 3CX's forum started reporting anti-malware detections for both Windows and Mac from the likes of like SentinelOne and other anti-malware engines, basically saying, hey, it's flagging this as malware.
Do something.
Yep, exactly.
By the way, if we pause right there before the forum, 3CX is basically like a VoIP phone company, right? I never heard of them, but they have a Mac and Windows desktop app for their VoIP, which is what these guys were talking about on the forum. Right?
Yeah, like a soft phone, basically.
Yep.
You know, typical Mitel kind of thing where you can dial in from your desktop instead of having that physical thing on your desk that is currently unplugged on mine. I'm pretty sure
we
that
just
even
have little computers. We don't use phones anymore.
My secret is even when we were in the office, my phone was physically unplugged for I think at least the last 2 years before the pandemic. People knew to call my cell phone if they needed me. That desk phone was useless. But anyways, so unfortunately, some 3CX support reps initially waved it off as like false positives, which is somewhat understandable. Like from a security company, like, I mean, I don't know about you when you worked in support, but when I worked in support, I mean, we tend to have false positives occasionally for software.
If there's a legit company, you know, you might assume that. By the way, one bad thing that security companies do, I think we'll talk about a positive for ours later, is when, like, if you have legitimate software and it's digitally signed and it looks like it comes from the right place, you would probably assume a false positive at first. You wouldn't assume someone's been hacked.
Exactly. Yeah. And as we'll get into it, both of the malicious files that were a part of this supply chain attack were legitimately signed to one degree or another. So the incident's since been attributed to Lazarus Group, which is our favorite friends from North Korea.
Oh, North Korea.
We've talked about them quite a few times, typically responsible for like cryptocurrency heists or ransomware extortions, WannaCry, like all sorts of fun stuff. Allegedly, I mean, yeah, you really even have to say allegedly. Okay. So the infection started with a malicious update to their desktop soft phone applications, both Windows and Mac. These applications, they run on something called Electron. It's basically like Chromium, the web browser, that lets you build a website as an application. Yeah. It's kind of neat, very powerful, but along with it, you can bundle other libraries to use within like native Windows or native Mac OS. And in this particular infection, there were 2 malicious libraries that were included with the infection. So on the Windows one, at least, one of them was a library that was a legitimately signed Microsoft DLL that the attackers had modified to include a encrypted malware payload. And you might think, so if it's legitimately signed by Microsoft, how did they modify it? Because that should affect the cryptographic signature, which should no longer be valid. Turns out, it actually goes after a 10-year-old vulnerability in Windows that is a opt-in fix. Basically, at a super high level with cryptographic signatures, you're taking a hash of data and then cryptographically signing it with a key to prove that you are the owner or author of that data. So it turns out that signature it doesn't sign everything in the executable. You can actually modify parts of the EXE's authenticode section and add additional data in there that is outside of the part that is signed. And so this opt-in fix is to also validate that as a part of the signature. But it's opt-in because it actually breaks some stuff. Chrome actually being one of them for a while, where if you check that like opt-in to sharing all of your information with Google checkbox when you install Chrome, it actually technically it would modify the signature of the file if you had opted into this. Yeah. It might cause some alerts throwing off. But anyways, in this case, it was a legitimate library that they had modified to have encrypted malicious code inside. Then there was a second library, which was a malicious copy of FFmpeg, a really popular open source video encoding
compressor.
And in this one though, so originally, if we back up a little bit to like the announcement of, this attack that had affected 3CX, they pointed at FFmpeg as the source,
potential source. Yeah.
Which, if you just take that on face value, that makes sense because we see third-party libraries being an avenue into software.
It happened with some Python libraries, I think we've talked about before.
But FFmpeg actually came out and said, actually, our repo is fine. So the infection occurred somewhere after 3CX downloaded the source code and then compiled it locally within their own build environment. So that malicious copy of FFmpeg, its whole job was to go in and pull out and decrypt that malicious code from the other Windows library and execute it. That was basically just a shellcode loader. It would then go up to a hard-coded GitHub address and pull down .ico files, so what should be just a small image, but tacked onto them, they had base64 data that ultimately...
basic encoding to obfuscate things a little, but...
ultimately had to go download additional files, which ended up being information stealers for most of the part. Now this was, at the time, it seemed like, okay, Lazarus is just throwing out a bunch of info stealer Trojans and stuff, which, whatever, maybe it's for espionage. North Korea isn't beyond that. The latest update I saw today, though, was they appeared to target a specific class of organization with actually a secondary payload. Another type of backdoor. It was
this is a typical way to target, where they might. I think they did it with CCleaner too. I sometimes say CCleaner, but it really is just CCleaner.
ATM machine.
Yeah, where I think 3 million people downloaded it, but they were checking the malware, which was in the installer for 3 million people, actually looked at aspects of the computer and only called to get the real payload if you were one of the more targeted people. They weren't trying to get millions of people that were using CCleaner. Same probably with the SolarWinds one, but they knew customers of that product, and in this case it sounds like they might know customers of this product that they're looking for.
Exactly. So the ultimate payload that they installed on this select group of customers that I'll get to in a second was the GoParum backdoor, which is basically just a typical backdoor Trojan. You'll never guess what the category of organization is that they went after, though.
Healthcare or cryptocurrency?
Cryptocurrency companies. So there was a non-zero number of cryptocurrency companies that were specifically targeted with this secondary backdoor payload.
I guess cryptocurrencies use 3CX
soft
phones,
which really raises the level of certainty of this is Lazarus from medium to ultra high at this point. This is very much their modus operandi.
I think Sentinel-1 crowd, there's 3 different companies that were researching this at once, and they all seem to share that it was TTPs. They still say allegedly because they don't want to get in legal trouble.
Some of the TTPs were there was a piece of the shellcode loader that was byte for byte a copy of previous Lazarus activity. So, while that doesn't stop someone from going and stealing it and reusing it, the reality is it's pretty likely, decently high certainty that it was Lazarus. So, all things considered, 3CX, they pushed out an update. They also pointed their customers towards a browser-based version of the soft phone client. So it turns out it can run entirely in your web browser.
So the CTO said, I don't even know why we do the normal download. You all should be using the browser version anyways, although that seems like
that would have been nice to know before. But, it happens though. It's tough to throw stones in glass houses because it could literally happen to any organization. This seems to be a fairly
I would
targeted
hope
attack.
those source code servers. I mean, yes, any organization could have its sophisticated actors, even if they didn't get to the source code, because it could have pivoted their way in with even someone that takes security seriously. But it is pretty scary and a big deal when they get that far into your company that they control your legitimate packaging.
Yep. If you are a WatchGuard customer with at least endpoint protection, EPDR would have protected this from day zero with both the heuristics rules.
DNS
and some of the
Watch
advanced
has some
protections.
domains. In fact, I think we've contacted customers who we've seen reaching out to get this malicious download in a certain period of time.
Exactly. Yep. So like there are protections out there. Obviously, other anti-malware engines were alerting off of it weeks in advance of the cat getting let out.
Wasn't a
of
false
too.
positive. Should
Correct.
listen to the forum earlier.
And man, it's just another example of a supply chain attack that could be used against very specific targeted organizations, but also potentially wide-ranging ramifications too.
And very much like the deepest supply chain attack. Sometimes I loosely use supply chain attack for when a third-party company introduces software vulnerabilities into your organization. It's being a supply chain attack. But really, this is the most supply chain when the actual victim organization's own software has been booby-trapped.
Exactly. So, this is like basically it feels like SolarWinds 2.0
for sure, or CCleaner 3.0.
Yeah, or
name the others.
Exactly. So if you are a 3CX customer, make sure that you have upgraded or started using the other application. Probably time to do some data forensics.
If you downloaded it in the past 3 weeks,
there's
check it out.
IOCs on our Secplicity post that you can look into in your logs to make sure that you weren't a potential victim of it if you are a customer as well. And if you were, time to start doing incident response, unfortunately. So moving on, also last week, several university researchers put out a new white paper titled Framing Frames, Bypassing Wi-Fi Encryption by Manipulating Transit Queues.
Finally, a Wi-Fi industry hack. It was like 3 years ago when one of our predictions was, what was it? I think it was
around WPA 3, I think, had just started.
And it had some sort of hotspot, some ability to downgrade, or the carrier could force it to go to Wi-Fi networks if they were nearby instead of LTE using something in W3. And anyways, we said that there would be maybe some new Wi-Fi attack, and it would be based on the new WPA 3 standard. So I'm not sure if this covers it, but is this something, Mark? Can you tell me more about it?
Did our prediction come true?
3.
And in fact, some of the WPA 3 specific security protections, like protected management frames, PMFs, actually protect against some of this activity. Not all of it, as we'll get into. But this is a protocol vulnerability. So it's not an implementation vulnerability.
Industry-wide.
Although the implementation is a very high factor in how exploitable it is. We'll get to that in a second. But it's actually a vulnerability in the protocol itself, like how they define how to do wireless.
Yeah, a specific part of
the 802.11 standard,
sleep.
which I'm sure that everyone here has read the entirety of the 802.11 standard for wireless standards, whatever. So also a proof of concept has been released too by the same researchers. They call it MaxStealer. So you've probably heard that name floating around if you read the InfoSec news. But the vulnerability, it's all about a power saving feature in 802.11 that allows an access point, so your wireless access point, to buffer transmit frames. So messages it's going to send to a wireless client, it can buffer them if that client tells it that it's going to go to sleep for a little bit. Basically, your wireless radio and your laptop and your phone and your watch and everything, it's actually pretty power hungry to run constantly.
Yeah.
And so a wireless client has the option of sending a specific frame to the access point with a bit set that basically says, I'm going to sleep.
Leave me alone for a bit.
And when the wireless access point gets a message from that client with that bit set, it goes, okay, it's sleeping. I'll buffer all of the messages I was going to send to it until that client sends another message saying, I'm awake. And then the access point will send all of the messages. Okay. So sounds like a great idea. You know, it allows you to not just have application packet loss. If it were to just drop the messages, it can queue them up on the access points.
Yeah, I'm sure it's a great idea as long as you keep those buffered frames encrypted, which I'm sure they did, right?
Exactly. Unfortunately, that is not the case. And all of these buffered frames are actually typically stored unencrypted, and then it figures out the wireless encryption when it's ready to send.
When it wakes up, I assume it has to
and unfortunately, in some cases, but unfortunately, this is not well defined in the standard. And so depending on the access point you have, it could potentially handle it a little bit differently. And in some cases result in sending out packets in a way that a adversary somewhere on the network could have visibility into them.
And injection capability.
Exactly. So basically what they found is an attacker can hop on a wireless network and then spoof the MAC address of another client. So pretty traditional.
It's the server side, so you have to pretend to be the AP. That's
in this case, you pretend to be the client.
Okay.
And as the client, you send a spoofed "I'm going to sleep" message to the access point. So that particular message is not protected by the new WPA3 standards.
Pause there. Would Mac filtering? I guess smart attackers could change their Mac, but since you have to spoof a client, if you have any Mac-based protections on your AP that says, Corey's machine that someone's trying to spoof is this MAC address, only that MAC address join.
Well, the issue is it's targeting your laptop itself. So it's like, I'm the bad guy. You're sitting there connected to the network. I guess the initial high lift.
So they must be doing MAC spoofing.
I have to know your MAC address. So like be sniffing the wireless traffic or whatever. Yeah. And I say, all right, I'm going to target that guy. So I spoof my MAC address to look like yours.
So they are using MAC spoofing.
Send a sleep message and the access point goes, okay, I'll start buffering those messages. Yep. Then they found that if the attacker is able to trick the access point into like rekeying or restarting the association with that client or some other implementation specific opportunities, they can potentially then send a wake up frame. And when the access point sends all the messages, it will send them under this new security association context. So it gets a little bit technical, but basically at a high level, the attacker will trick the access point into thinking the victim is sleeping. Then they go in and try and change the security association. So they found that if you send like I forgot the exact message, but like security association rekey or something, the access point will start, either it'll delete the key and start a new association. Maybe it'll let the attacker spoofed client just completely create a new association so they know all the keys. In some cases, it deletes the pairwise key and starts using the group key, so one that everyone on the network has access to. And in some access points, it just deletes it entirely and no longer encrypts the messages. And then when the attacker tells the access point it's awake now, pretending to be the client, the access point will send those buffered messages, either using the key that it now negotiated with the attacker, using the group key, which the attacker can get access to.
I assume you'd if you use the key negotiated with the attacker's now taken over the connection, but it won't be able to actually see that one. That client wouldn't be able to connect anymore, the victim, because it's a new key.
They would have to reconnect themselves, which should in theory work.
But would it kick the attacker off, or would the AP just rekey using the key the attacker has?
I have to imagine it depends on the access point and how it handles that.
But with the group key or no key at all, the attacker, both the victim and the attacker will see all the traffic.
So the big caveat on this, in practice, they found that removing or renegotiating that pairwise key, the client to server one, is very device dependent. They found that in some access points, it will drop the key if it receives a new association request from the client. In other cases, the wake up message is enough to cause the key to be removed. So they don't have to do anything extra. They just tell it to sleep, tell it to wake up, and it'll drop the key on that wake up and just send everything unencrypted.
Lovely.
Exactly.
My job is done as an attacker.
So they described one attack scenario. So picture I'm trying to target you and I know you're connecting to your bank account or something. And so I wait until you send the request to get your bank account password, to get something sensitive out of an online account. Then after you've sent that request from your client, I then go tell the access point you're asleep. I then take over your security association. Then I tell the access point you're awake. It sends the reply from the server, and now I, as the attacker, would have visibility into that packet. Now, that said, this also requires there to be no application or transport layer encryption on that activity.
No SSL TLS to your bank.
So if you're using HTTPS, you're fine.
Yeah.
So it's really a target.
An SSL strip that we used to demo all the time does not work on modern devices. So use tough. HTTPS. More importantly, if you're on Wi-Fi, you don't control, use VPN on top of it.
Exactly. So if you're if your communications are protected with transport layer encryption, you're in theory fine from this. Like, I guess if you're using Telnet to go hop into a system, like you could be
That's a
vulnerable to
problem.
this.
Yeah.
It's also a very opportunistic
And what
attack.
site isn't? I mean, even non-bank sites, I think Google says
It's like 99.98% is encrypted these days.
So there's not much you can inject. I mean, even to inject, you'd need someone to be going to a clear text site to inject something.
So in very specific opportunistic cases, an attacker in the perfect setup in a basically controlled environment could potentially view unencrypted wireless packets sent back to a recipient.
Yep.
Can't view the ones sent from it, but it could read those replies. They did, though, propose a denial of service vulnerability in the same kind of context, too. Because if you remember that message telling it you're going to sleep, tells the access point to stop sending or transmitting frames back to the client.
Yeah.
And so as an attacker, if I sit there and just keep spoofing,
night.
I'm asleep, you could, in theory, do a denial of service against the client. And that is not protected by the protected management frames from WPA3. One of the other demos or hacking techniques we see is sending deauth packets as a denial of service attack.
Yeah.
That is protected with WPA3 protected management frames. So this is a way to kind of circumvent that on newer networks as well, too. So at least that is a bit more of a practical attack than this potential
injector.
Exactly. So, I mean, that said, it all is contingent on that the actual application that you are receiving.
Still worth patching your APs. The Cisco, I think they tested Cisco, D-Link, and a few others are known vulnerable.
Yep.
By the way, what about us? I mean, we have an access point. I know we've started a query for this, but I don't.
Currently investigating. My gut tells me we're technically vulnerable, but the reality is still it's
going to be low.
It's opportunistic, and it's not as serious. It's a cool vulnerability, but it's not like a, oh my God, Heartbleed style vulnerability.
And by the way, of course, we'll have an update somewhere, whether it's PCERT or whatever, when we do know more about our product.
And we'll hear more from the researchers after Black Hat Asia, which I think is next month, where they're presenting their white paper, and I'm assuming some demos on this too. So
it'll be interesting to see the demo. I think a lot of the security folks, like you said, feel like it's a cool flaw from a research perspective, but pretty low impact severity. But it'll be interesting to see if any demos change people's minds.
Yeah, exactly. So we will see. So now moving on finally to the third story, the cloud security vendor Wiz. There's no
Wiz is how I would say it.
I'd
There's
say
no
Wiz.
E. I'd say Wiz.
But Wise, I can
see.
see.
Kind of nasty though. Wiz.io.
Yes, exactly.
Maybe it is a funky way to be wise, but there is no E, y'all.
Correct. So Wiz published an article last week describing a developer mistake that could have allowed them to take over Bing search results.
I love the name. Bing Bang.
They called it Bing Bang, which it's fun to say that over and over and over, of course.
By the way, right away, take over search results. That's like, you'd think this is a big, nasty, huge issue. I guess it is, but it seems like such a little simple issue. And bam, I can literally make people go to my site first on any search result. Is the pretty big impact. If you think about, if I'm a bad guy, I know popular search terms, and I can get Bing to always respond with me as number one.
Mm-hmm.
That's a lot of power, man.
And as you'll see, like they use Bing as the example here, but it's actually a wider ranging issue in Azure in general. So they found it's based off a common Azure Active Directory misconfiguration for applications that developers deploy.
People don't misconfigure Azure cloud stuff. All IT guys totally understand the new cloud capabilities of AWS and Azure. They're never misconfiguring things, Mark.
As you will see, that is very wrong. So basically,
didn't hear the sarcasm.
They found several Microsoft applications are vulnerable to the attack, one of which was the management system that powers Bing.com, or at least one of them. So basically, Azure Active Directory has several different types of access for an application. It can either be single tenant, so people within your organization can log in and access this app. It can be multi-tenant, so shared between different ones, or personal accounts, so like my Gmail account, or any combination of those latter two. And with a multi-tenant application, it technically allows logins from any user on any Azure tenant, and it's up to the developer to check that user's tenant and provision access accordingly. And if they don't, It means that any user in Azure can log into that app. And unfortunately, this is not a very clear security weakness, boundary, configuration, whatever.
Nothing documented or told to the developers who were making apps.
So WizWise was whatever found that 25% of multi-tenant applications that they scanned allowed access from any Azure user into them. One of those was a Microsoft app called Bing Trivia. And so in the app, they found access to a content management system, a CMS for Bing. So they went through, and as curious security researchers that are kind of pushing the boundaries a little bit, they wanted to confirm that the CMS was controlling Bing's live search results. So they chose the keyword best soundtracks as a search query and changed the first result, which was Dune, the 2021 movie.
Good soundtrack.
Pretty good soundtrack. They changed it to Hackers, the 1995 movies.
Great movie for our industry.
Slightly worse soundtrack.
Yes.
And they found that immediately appeared in Bing at the very top if you went to go search for best soundtracks.
That was a little risky already for like a pen test that you assume they haven't asked for permission to do yet from Microsoft.
And this was technically out of scope for Microsoft's bug bounty program too, which we'll get into in a second. So they're very much on a gray area right here.
Yeah, they
didn't stop there either, though.
Yeah.
They also went to see if they could inject JavaScript, which they ultimately found they could.
Cross-site scripting attack.
So in theory, they could have stolen a authenticated user's authentication session token out of there. So basically compromised any Bing user that went to Bing to search for something. They reported this, at least the Microsoft instance of the flaws, to Microsoft. They resolved them, gave them like a $40,000 bug bounty, which they donated to charity because they're kind people. But that's still, there's 25% of all Azure apps out there in multi-tenant mode are vulnerable to this style of attack. So their mitigation recommendations, first off, if your app doesn't require multi-tenancy, turn it off, switch it to single tenant. If you do need to grant extra access, use conditional access policies to restrict who is actually allowed to access the application based off of things like the actual tenant they're coming from. I don't know where they're coming from in the world. You can conditional access policies in Azure are pretty robust. But I do like the name Bing Bang.
Yeah, Bing Bang.
From a research perspective, it really does feel like they went a bit over a gray line in this one. Like I personally would have not felt comfortable modifying.
Temporarily modifying a search result for 2 minutes, I would say passable, but actually exploiting the cross-site scripting is a little more. I mean, they still did a POC exploit, I'm sure but you're playing with fire.
Yeah.
Good thing Microsoft Trustworthy Computing is all about fixing flaws, but yeah.
I'd say if you'd done this 15 years ago.
On the other hand, I mean, let's be devil's advocate. I'm glad this was a lot of power. Imagine a nation state being able to make, the top 5 search results for popular things, anything they want, and silently injecting JavaScript that grabs all your session cookies from your logins, because that's what the cross-site scripting could do for any people that clicked on that search link to go through it.
Yeah.
So a big deal. And if they weren't able to test, they wouldn't be able to report. So I guess I'm happy that Microsoft gave some leeway and paid out and isn't taking them to jail or anything.
It's true. But I mean, 15 years ago, Microsoft, they would be in prison.
Probably.
Very much different company back then. But yeah, Bing Bang, good find. If you are a developer of apps,
like something
on Azure,
Trump would say, Bing Bang.
Bing Bang. I don't know. It feels like something out of Arrested Development. I'm young. If you are a developer of apps on Azure, maybe go check and see what your access settings are for those applications. Yeah. Make sure you aren't one of those 25%ers. But
don't use Bing as search either.
Hey, I don't know. The AI implementation
Didn't they add the Chat GPT
cool.
first?
Yeah,
with all the hallucinations on top of it.
Man, yeah. What a time to be alive. Hey everyone, thanks again for listening. As always, if you enjoyed today's episode, don't forget to rate, review, and subscribe. If you have any questions on today's topics or suggestions for future episode topics, you can reach out to us on Twitter. I'm at XORRO_. Corey's at SecAdept. And the both of us are at hashtag the 443 podcast. Thanks again for listening, and you will hear from us next week.
Peace out, y'all.
Mic drop.